Hi, this is Bridget Kidd, and today I'm going to be explaining the Doppler effect and how it can be used to show that the universe is expanding.
What is the Doppler effect?
I have no clue what the Doppler effect is.
What is the Doppler effect?
Some kind of communist propaganda.
What is the Doppler effect?
So what now?
What is the Doppler effect? What?
Okay, so our grasp of the concept isn't too great, so let me explain. The Doppler effect is a change in the observed frequency of a wave, as of sound or light, occurring when the source and the observer are in motion relative to each other, with the frequency increasing when the source and observer approach each other and decreasing when they move apart. What? So here's an example. Two guys are playing football. The one with the ball is like our source. The one who is catching the football is like our observer. The arc of the football is like the wavelength. The above case is what the wavelength actually is. When the observer moves away from the source, the wavelength gets longer. This longer wavelength means that the frequency is lower, as frequency and wavelength are inversely proportional. The second throw is made this time, though. The observer is moving towards the source, causing the wavelength to be shorter, thus having a higher frequency. Now, let's use this same concept with sound. When something approaches and passes you, such as a skier or a jet, it sounds like the object is emitting a higher pitched sound when approaching you than a lower pitch when it passes you. You may have heard this with a siren as well. This is because the frequency is higher as the wavelength gets shorter when the object comes closer, and the frequency gets lower as the wavelength gets longer when the object moves away. You know what else has these properties? Light waves. Yep, the Doppler effect happens with light too. But we can't hear light waves, so how do we know that the frequency changes? Color. Yep, we are going to wavelength in nanometers. Well, here's the electromagnetic spectrum. What color has the longer wavelength, red or blue? Red. Red has a longer wavelength and thus a lower frequency compared to that of blue light, which has a shorter wavelength but a higher frequency. So, what color do you think the light emitted from all of the galaxies would be? Red or blue shifted? Well, if the galaxies of the universe are moving towards us, then they would be blue shifted, due to the shorter wavelength and higher frequency. If the galaxies are moving away from us, then they would be red shifted, due to the longer wavelength and lower frequency. Now we look at the observations. Astronomers have found that the light from the universe is redshifting, showing that the universe is moving away from us and expanding in all directions. So this is proof that the universe is expanding using the Doppler effect. Wow!
I went walking with my mama one day when she warned me what people say. Live your life until love is found.